Hi everyone. So my name is Christian, and in this video I'm going to be presenting Hysteresis. Hysteresis is a Python library that I wrote, and it can be used to process curves. As the name suggests, it's particularly suited to help with processing hysteresis data curves. So if you are a researcher, you're probably going to be processing a large amount of experimental data. In my field, structural engineering, this might look like something in the image on the left. So we'll maybe test some sort of shear wall where we're applying some sort of force to the top of it, and we'll end up with some sort of force displacement hysteresis curve that we want to process. And we're probably going to end up with a large amount of this data. So we might want to know specific things like the peak value at a particular point. We might want to know the backbone of our curve, or we might even want to know the area under our curve. We also might want to compare two different hysteresis. So currently, if you ask the question, how similar are two hysteresis, there actually aren't very many good tools of comparing them. The best that we normally get is if you're a researcher, you'll see this in a paper, they'll take like your experimental and analysis hysteresis, they'll put them on top of each other and be like, all right, they look about the same. But really, this is not the most sophisticated way of comparison, and hopefully some of the tools that hysteresis provides will let people do this in maybe a better way that's a little bit more sophisticated. So traditionally, if you are processing your data, you're going to be using some tool like Excel, like MATLAB. You're going to be developing your own scripts, and it's kind of going to be a one-off. So you'll need to come up with a script that processes the data. You'll use it in your experimental program or research program, and then you'll just forget about it forever. But this is actually pretty painful of a process. It can take a lot of time from high-level research tasks, and really, as a researcher, we don't want to be doing a lot of this data processing. We want to be, thinking about our research program in other ways. So hysteresis is a potential solution to this that I came up with in Python. It's an open source project. And really, it's meant to be there so you don't have to completely start by scratch if you want to do some of this data processing. A simple script for hysteresis is shown on the left. So the first little bit, let me get my pen. We're setting up some curve, and this is just very simple in NumPy. And then this we're pulling in the hysteresis library, we're making the hysteresis object, and we're plotting it. And you can see that plot on the right. And in particular, we can see that the reversal points have been detected. And now those are our little X's over here. So hysteresis has found where these reversal points are and kind of knows that. So the common things that we'll be doing with hysteresis, we will be making plots. And I'll get into it later, but hysteresis is integrated with matplotlib, so you can make publication-ready plots from it. You will be doing you can use it to do a lot of common data analysis tasks, and then you can also do it to do some more sophisticated things like comparing different hystereses. Hysteresis is an open source project, and you can see all the code online on GitHub. It is also set up as a pip package, so you can easily install hysteresis using the commands that you're used to. The way hysteresis works in the background is it represents curves with different data types. The highest level data type that exists is the hysteresis curve, and so we can think of the hysteresis curve as something that can change direction both in x, so you can see we're going up, and then also in y. So we can see this curve, the whole green, It's changing, it's going up in X and Y, and then it's changing directions. We can break this curve up based on its reversal points into a simpler representation. So we can break a hysteresis up into a number of simple curves, and these do not change direction in X. There might be a few jitters where we're kind of maybe slipping back slightly, but as a whole, this curve is only going in one direction in X. And so we can break our hysteresis up into these simpler objects. We can even go a step further. There's another representation, the monotonic curve. And monotonic curves do not change in the y direction. So a monotonic curve, and again, we're seeing some small slips here, but the curve is basically going in one direction in both the x and the y. And so this is something we can configure hysteresis to find these different regions of the curve, and also ignore some of these smaller things that we don't care about as much. So this is a basic example using some plotting. We can load some data over here. We can create a list that contains it, make a hysteresis object, and then plot it down here. And that shows up on the right. As I mentioned, hysteresis is completely integrated with matplotlib. So if you want to, like the figures that it kicks out here, these are matplotlib objects, and we can modify them like we would modify any other matplotlib chart. So we can make very nice figures that you can put in some sort of research paper. As we can see, by default, it's gonna erase. Okay. By default, the reversals are detected, and we can see that it's found all of the points where we're changing direction. We also can highlight specific regions of our plot. As mentioned earlier, the hysteresis will break up the object into a number of simple component curves, and we can say highlight these curves. So here we're saying, okay, I only want to plot the third from last cycle or the second from last cycle, and that's what we're seeing in these two plots. So that's kind of neat. We get to extract particular cycles and see them if we want. Other things you can do during hysteresis, there are functions set up. So if we set the area of our curve, or say set the length of our curve, we can extract things like area under the curve at each point, slope. So we can see that here. So here is our base curve, and then the orange curve is the area under the curve that's at each point. We can also do things like find cumulative area. So if we know the area under the curve, we can sum it all up and get cumulative area or energy contained under the curve. Hysteresis can extract the backbone from an existing hysteresis object. We also can do things like, if we have a backbone curve, we can fit other curves to it. And there's some existing functions that can, for example, fit an equivalent energy plastic curve to a backbone curve. Another more sophisticated thing that we can do is there's actually functions to resample a curve. So if we start off with our base curve in blue, we can ask for a curve that has just 5 segments based on that original curve. So we can see here's segment 1, 2, 3, 4, 5 between these points. Boop, boop. And because we can do this, it actually becomes easy to compare 2 different curves. If we say had a lower curve down here, we could resample these 2 curves and do something like we're seeing on the right. So if we have curve 1 and curve 2, we can resample each curve and compare how close they are by looking at the distance between the 2 points of the curves that have been resampled. And so this gives us an idea of how two cycles might be similar. Because we can do this for each cycle, and we can break up each hysteresis into its cycles, we can actually compare each hysteresis. So we can, for example, at each cycle, compare how similar those are. So resample each cycle, and then get something like we're seeing on the right, which is showing for the number of cycles how similar each one is. And so that's nice. We can actually qualitatively compare these two curves as a we can actually quantitatively compare these two curves as opposed to qualitatively comparing them, like showing them on top of each other. We can also use this because we can compare two hystereses. Now we can actually say adjust parameters in our model and fit an experimental and fit a numerical curve with an experimental curve. And that's done in this GIF that I have here. We're actually using a genetic algorithm to change parameters in our numerical model so it will better match the experimental hysteresis in blue. So that's kind of cool. And so that's hysteresis in a nutshell. In addition to everything I've shown, there's lots of documentation. There's a Read the Docs website that you can see on the right. There is a lot of examples that have been put together painstakingly on my end. And there is also a research conference paper that describes it and some of what's going on in the background for all the nerds out there. So if you use this, I hope it's a useful tool. I hope it saves you a lot of time and that you can do better research with it. All right, that's it. Thanks for listening. See you next time.